Hello everyone, welcome to today's video. Today I'm going to teach y'all how to forecast tornadoes. Once you get the hang of it, they're actually not that hard to forecast. So let's go ahead and get right into it. First part is weather models. One website that I recommend, actually there's two websites I recommend, but the second one I don't have shown here. The first one is Pivotal Weather. Pivotal Weather has a lot of great models. And the College of DuPage, they have good weather models in parameters also. If you want to check that out, I'll have the link in the description for both of these websites. Actually all the websites mentioned in this video. So here, we just teach you the interface. These are the forecast hours, from the current time that you are in right now. So, at the time of recording this is 11:42 p.m. So, this would be, I believe, 240 hours from now. Yeah, so this would be, oh, well, here you go, we got a new, hour. This would be 246 from right now. So we got a bunch of stuff. I don't usually use this. I only use around like 5 things. So there's 500 millibar height and wind. So you can see here's the upper air dynamics. There's severe weather. I use most of okay. Bulk shear sometimes, and supercell composite. Supercell composite can sometimes be deceiving, but it can sometimes, and I mean sometimes, reflect the kind of dynamics in the atmosphere. We'll take a look at that later. You got upper air dynamics. You can see vorticity. That will have to be saved for another video. All this nitty gritty atmosphere dynamic stuff. Temperature 2. I'm gonna teach you a few. So as you can see, let's go over here to this main page. As you can see, it's kind of hard to see things. In this video, for all the things we're really looking at, we're gonna be looking at, except for later in the video, when it comes to weather models ish. We're going to explore soundings, which I'll explain those later. We're going to be looking at this area because this is currently experiencing some slight severe weather. So I think it'd be a good example for us to look at. So, just a few tips and tricks, since you can't really look at very specific, since what it looks like you can't look at very specific things. Here's a few tips and tricks. So, first of all, you probably don't want to be just clicking through all of these. That can get really draining. So go to this animation and click forecast loop. And then that will load up all these images. Sometimes it can take a while, especially with GFS. It's a very, very long range model. It can forecast like 2 weeks in advance. I've been using this to look at the 20th of July. See if maybe that'll be a good day to go chasing last time this year, until maybe Dixie Alley tornado season. So as you can see, here's the forecast loops, or the images that are currently loaded. If you have a trained eye, you can see low pressure systems, and high pressure systems too. Right here. Also, these are called wind barbs. The little feathery thing points in the opposite direction. So think of this like an arrow, from a bow and arrow. You've got the feathering on the back of the arrow here. There's the tip of the arrow, and obviously it points in the direction you shot the arrow, because I mean it wouldn't aim up. That's not how aerodynamics work. Think of that as the wind direction and speed. I think this represents like 1 mile an hour. These little tick marks, and there's like little triangles that represents 5, 10. I don't know, or maybe these half ones. I don't know. I don't know. But as you can see, wind direction. If you have a trained eye, You can actually see this is a low pressure system because it spins in a counterclockwise direction, which all northern hemisphere low pressure systems spin counterclockwise. So as you can see here, as you can see, that spins up, kind of just goes away, and this is actually called the jet stream. I'm looking at the jet stream right now, which is just like waves of air. So you can see there's another low up there. You can see it kind of whoosh, like that. So yeah, that's forecast loops. But let's say, looking at it right now, it's like, oh, there's a little bit of shear. Maybe there's like a little bits of shear I can't, or a little bits of wind or something that I can't see. We just find. We're just gonna pretend this is shear. This is by no means an exact shear parameter. I think this is both shear and the jet stream. So if you can't like see it, it's like, oh, so tiny. You can go to zoom. You can go, assuming you're in the U.S., continental U.S., regional, United States, and Midwest U.S. And now you've got a more detailed picture of what the stuff is looking like. Like, I didn't see this. Like these little like higher parts of wind shear-ish, I never saw these because I was so far zoomed out. So it's a very useful tip / trick to use. Ooh, that's a good wind right there. And if you click just anywhere, you'll get what is called a sounding. Now I'll get into these a little bit later, but let's move on to the next thing. So this model's for long range forecasting. The farther out you go, the more uncertain things get. Just a tip / reminder. So this is a really good short range model, very high, like a high resolution. It's called HRRR, which stands for high resolution rapid refresh. Now, when I use HRRR or her, I like to use this explicit. I like to use this one of the explicit convective products called reflectivity updraft helicity, which basically shows composite reflectivity combined with forecasted updrafts within a storm. So if we go, hopefully we'll see something like this. Okay, no, we won't see it on this run exactly, because there's nothing really happening right now. Because the severe weather risk is really ramping down. Again, this is recorded at almost midnight. But you'd see these dark streaks. I'll put up an example here on screen of May 20th, 2019. By no means is that a reliable HRRR run. That was a very inaccurate run in what happened. In order to what happened, this is just an example of what it can look like. What the forecasted updrafts actually look like. Okay, so now done with the interface and different models. Now you gotta look at the parameters. What is all this? It's so confusing. This is called 0 to 3 kilometer at the ground level cape. I believe this is 3 cape. Yes, this is 3 cape. 3 cape is really important in updraft stretching, which basically can cause tornadoes to form. So when you get a lot of surface vorticity, which is basically spin at the ground, you can combine with those, you can actually get tornadoes and land spouts too. You can forecast land spouts really well with the land spouts and tornadoes with those values really well. So let's look at some other parameters. So here we've got mixed layer cape, which is basically just cape, but they're using pretty much all the levels / layers for it. So actually, as you can see from right now, cape starts to die down, and boom, it starts to ramp up because there's actually supposed to be some severe weather over here in this area tomorrow. I'd look at there now, and I don't feel like switching because this is the area we're using. So again, using the forecast scrolling thing, you can use that to kind of like see how the cape kind of rise up like that. It's actually gonna be like, I think this will be like midday tomorrow. It's gonna be like mid to late afternoon, which is when all this cape is gonna explode. And by the way, this risk is like farther back, so I bet there would be more cape back there. And then we've got mixed layer convective inhibition, or mixed layer SIN. This can actually, so convective inhibition, what it means is it basically shows how much stuff is in the air, or like a cap, I think, that prohibits storms from forming. So I'm going to go to question mark here. SIN is a representative parcel, or piece of air, in a near-ground mixed layer. The parcel's temperature and mixing ratio are defined by averaging their environmental values, and the vertical over the layer. So as you can see, there's a lot of convective inhibition here, but it's also because we've got those storms dying down. Also, if you take a look at this very interesting thing, along with our cape earlier, you see convective inhibition kind of really sort of rise. But then as you see that, but if you kind of pair it up with the time that the cape is coming in too, you see that starts to go away, which means a lesser strong cape, probably eroded away by morning storms, which can actually sometimes be pretty useful. You've got like bulk shear 0 to 1 kilometer, bulk shear 0 to 6 kilometer, which basically just means wind shear, which is the change in wind height and direction in the atmosphere. Change of wind speed and direction with height in the atmosphere. So good shear equals. Actually, fun fact. Hail, I've heard, prefers lower shear environment. So if you see like high sheared environments, you're likely to get tornadoes and maybe some big hail, but not like monster hail, not like 4-inch hail. But if you get like smaller sheared environments, you get less tornadoes, maybe even no tornadoes at all, but you can get really large hail. So supercell composite, we already talked about that. Again, it's kind of deceiving, so I'm just going to leave that out. But as you can see, that explodes right there. It's giving an idea. Significant tornado parameters. Now we're going to watch South Dakota and Nebraska again, because that's where everything's happening tomorrow. So significant tornado parameters. Ooh, look at that. So significant tornado parameters, it basically just shows it's basically supercell composite, which is basically a combination of all parameters needed for supercells and combined to a value. It's basically supercell composite, but for strong tornadoes. It's kind of low. It's kind of low tomorrow. It's tomorrow, but tonight and tomorrow, as you can see, it's not great. I mean, it's possible there could be like maybe like a cone or something, I don't know, but not high values at all. Oh, what's going on? Why does it say advertisement on my crosshair? So that's pivotal weather, and then we've got the Storm Prediction Center. Storm Prediction Center is actually really useful. They've got basically forecast summaries. I would not by any means just read this and use it to forecast. Definitely use weather models when going out chasing or anything like that. So as you can see, there's categorical. There's a tornado here. Tornado, this shows tornado risk. This is only a 2% risk. It's a very small risk. There's actually another website that I'll include later in the video that I forgot to include beforehand. I just got reminded of it. We got the wind risk, which is 5% and 15%, which you can see as a slight risk. It's a wind-driven slight risk. and then just a 5% risk of hail in Montana and a little bit in North Dakota. A little sliver of South Dakota. So Storm Prediction Center is actually really useful. And then the Storm Prediction Center actually made their own forecasting thing, kind of like Pivotal Weather, but more / less freedom. All right, so here's what we were talking about earlier. I'd say the best value for forecasting tornadoes, along with other people. Credits to this part. For me learning this part, mostly to Skip Talbot. I watched his video like a while ago, like a couple weeks ago. I don't know, but this is where I learned this. So as you can see, there's not a high chance for tornadoes, really much throughout the rest of the night. You can see there's some 3 Cape and some vorticity, low vorticity, but moderate 3 Cape. So it's possible maybe like a brief unwarned land spout. I don't know. See, that really dies down by the end of the day. Also, if you're wondering about storm mode, that's going to be a different video. So you can see here's all the thermodynamics. You can see Cape 100 millibar mixed layer. The shaded blue is convective inhibition, which we talked about already, so we're going to move on. But the higher Cape, the better. 1,500 Cape, as you can see here. Okay, just 1,500 Cape here. That is considered sufficient for a tornado. So when you have values higher, like near or higher than that, like way higher than that, like sometimes like 3,000s, it's very possible you could get a tornado. Chances are still lower, unless you've got like a quote unquote on crack setup, like April 27th, 2011, which I might talk about in another video because that was a wild day. But yeah, so that's the mesoscale analysis page. We're all gonna go in a little bit. We're all gonna go back over the things. I'm gonna teach you how to actually forecast. Right now I'm just teaching you the terminology, I guess. And this is a sounding. It looks intimidating at first, but once you learn it, it's actually not that complicated. So first things first, this thing. It's like the main part, almanac, of the sounding. This green line, it shows dew point. Dew points from the surface all the way till like basically the top of the atmosphere. And so this is from I can't remember what date this is from, but we are gonna look at a good example and a forecast for tornadoes later in the video. And it was actually quite recent, just like exactly a week ago at the time of recording. So the green line, like I said, dew points. Red line is temperature, and this dotted white line shows the Cape parcel. And usually when you see this LCL, which is basically just storm bases, so when you see it like in between 0, like surface to 1 kilometer, that typically means like moderately-ish low storm bases. I'll go over all this mumbo-jumbo stuff in a little bit. This EL, which I know it has like its own little like name, but it's just storm tops. So basically how high the anvils are. So when you see high storms, like high top storms like this, and low base storms like this, that basically could be that's really good. That can be really good for tornadoes. So this sounding was actually from like late in the afternoon, and that's when this thing called the low level jet kicks in, which is a near daily occurrence where like cooler air sinks or something. Large area of cold air sinks, and so that can cause a lot of low level shear, which you can see here. the wind changes a lot in speed and direction and height, as you can see. So that's some good low-level jet-caused shear. And so one thing you may or may not notice is that this little kink in the Cape parcel, which is just a piece of air, big piece of air, Cape. When it meets, I was told by a good friend that if these kind of line up, it could mean a strong cap. And also, when you see these things meet up like this, like these lines meet up kind of like that, but like kind of closer together, maybe a little bit lower down, that can indicate a strong or moderately strong cap. And a cap is basically a temperature inversion in the atmosphere that can prevent storms from forming. So that's the main part of the sounding done, or that might just be sounding in general. Here's the hodograph. It's a bunch of like wind vectors all displayed on a map. Basically, there's an arch shape, which I've heard that an arch shape like this is really good because it shows lots of change in direction in the atmosphere. As you can see, possible hazard type, really simple to understand, tornado. With all these values combined, possible hazard type, tornado. I'll go over these sounding analogs and all that soon. So this little circle, this is the storm motion vector. And that can actually really help to determine storm mode, which I'll get to in another video. So let's take a look at all this stuff here. Cape 4,070. Like I said, 1,500 is sufficient for a tornado, and so when you get things like this, that is very high Cape. You rarely see that. LCL, which is just storm basis, is 576 meters. So that's like only about 1,500 feet off the ground. So it's like not even a mile up. So yeah, LCL, that's pretty low. Only about 1,700 feet around that area off the ground. So that's pretty good for tornadoes, which means that's how far they pretty much just have to stretch it out. Because higher base tornadoes means less likely to be tornadoes, because that means more updraft strength is needed to kind of like put the tornado on the ground. So as you can see, so 3 Cape was 76, which this was never mind. So this is 3 Cape, which, like I told you, is Cape from the 0 to 3 kilometer, from 0 to 3 kilometers in the atmosphere. So you can see, 76, which it's considered sufficient. 50 is considered sufficient / good. So this was some good. It was like, hey, that's pretty good. 3 Cape, which, like I said, can result in updraft stretching, which can cause tornadoes. Now, the sounding analogs, this basically just shows storms that came out of a setup with similar data sets. Like this, I think these two, I think this means they drop significant tornadoes, or maybe like significant winds or whatever. And this is significant hail, or significant supercells, I think, just strong supercells. Significant hail, this just shows you storms that have a similar data set that dropped big hail, or I don't know, just similar size possible hail or something. So you can see almost 3-inch hail and 2.5-inch hail. That's big. That's real big for hail. And so that's pretty much the not so basics of soundings covered. Okay, so using the new knowledge that you have, you can go back if you want. And kind of rewatch that. This is a real life example. Well, so is the other one, but I can't remember what day it's from. I can't really tell what it is either. But Using your newly attained knowledge, I bet you can guess what happened on this day, or take a pretty good educated guess. You can pause the video, think about it for a few minutes, and unpause the video when you're ready. So if you thought, because of this possible hazard type PDS tornado and this curve in this really large change in wind speed and direction and low level and upper levels in the atmosphere, high dew points, which upwards like mid 70s is a very high dew point, by the way, and a degree of 83 degrees. The smaller the gap, the better. And this, you can see they're smushed together, which is the absurd cape, and the LCL being at the Cape Parcel kink thingy. If you guessed that it was a very conditional day, but if a storm were to form, then a strong tornado would be possible, maybe even likely, you are correct. I'll put some pictures up on screen. I'll put a picture on screen of a large stovepipe tornado, like stovepipe wedge tornado. There was actually a supercell that produced wedge after wedge. I think it produced 4 wedges with photogenic rope outs, which is basically when a tornado dies and becomes a really pretty rope tornado. And one of them actually flattened an entire house, sadly killing 3 people. This was the tornado risk that day. They actually ended up upgrading the tornado risk like midday, because they realized that if storms were to fire off, then tornadoes would be strong, or could possibly be strong. And well, they were correct. Alright, so let's return to the models, and let's take a look at some possibly upcoming events that could help you forecast a tornado. Alright, so if we go... There's actually an upcoming chase day I am looking at around the Kentucky, Illinois... I almost said Australia, Indiana, tri-state area. If we go to 500 millibar height and wind, it's going to take a little bit to load. I'm actually not using the right model, just realized that. There's another model called CFS. There we go. It can forecast like an entire month in advance. It's not crazy useful. Like the farther out you go, after around 2 weeks, things really become uncertain. But this is just a practice. Think of it as when your teacher in school would give you that paper packet that would feel horrible on your hands because of the weird paper texture. If my pivotal weather would stop being weird. Okay, so pivotal weather actually ended up crashing. So let's take a look at tomorrow, and we'll see what it could be like for tornadoes, because there's only a 2% risk, but hey, you never know. This is actually right now. There's a 2.2 thing for tornadoes, actually. Oh, shoot. Marginal Tor. There's a risk for tornadoes at the time of recording this. It's a little concerning. For reasons I'm not sure I can state. But, if we use reflectivity, updraft, helicity, this should hopefully give you a good example of the updraft line thing. So it actually doesn't look like much right now. I'm sure new runs will come out, but let's just try our best to forecast tornadoes. Sometimes it's going to be really difficult depending on the weather setup and the risk. I am probably filming this at a bad time with not great risks, not great access to archives, but it's okay, guys. I'm kind of resourceful, so let's take a look here. As you can see, early morning storms can erode the cap. Let's actually take a look at that. We'll see if I'm right. Okay, you can see a lot of convective inhibition there. Look at that. As the day goes on, it's still a higher... Look at that. As the day goes on, you can see the cap starts to erode. So I was right. The cap will erode. If we go to mixed layer cape, it should... The cape should also explode around this time too. So around 15 hours from the time I'm recording this. Boom, look at that. See, it just absolutely blows up. There's a weird gap in cape. I don't know what that's all about. So you can see, just really high piece of the cape here. So let's take a look at North Dakota. Take a look at all states in this area. Not, okay, good dew point, but a very big gap in between the temperature. Lower, top storms, high cape. Ooh, this might... I don't think that's gonna be great. It's gonna be good for hail, possibly. As you can see, because the low amounts of shear, you can see there's not much change in wind speed or direction. But let's check Nebraska. You can see it tore. Look at all these. That's crazy. Okay, so sometimes, just a warning, models can overhype, but they're usually around the same. So I think tomorrow we could get like around 5,200 cape. Look at that. That is wild. LCL, that's a pretty normal LCL. And also convective inhibition won't be that high down here. What looks like it could be a possibly stronger cap, or like a moderately strong cap, as you can see though. Low level shear, some good shear. I think we could see some stuff down in Nebraska. And if you want to test this out yourself, keep track of the storms in these areas that I'm talking about. And hopefully I'll be right and you'll learn something. Like, you did that right, so it's probably how I should forecast. But you won't always be right. Just letting you know that. You will not always be right. Things can change. So don't expect to be good at this the first time or get it right all the time the first time. Because trust me, I was horrible at forecasting tornadoes like 2 months ago. But I watched too many videos and now I know a lot. So our forecast for tomorrow is showing some tornadoes. Actually, let's take a look at South Dakota. I didn't look at that. Sorry, guys. Ooh, huge gap in... temperature and dew point. That's not good. High cape, supercell. Ooh, that's high values. I think that's supercell composite. Yeah, I think that's supercell composite. I'll have to check. You can see some small shear, some smaller shear, like some okay shear. High base storms. Not crazy high top storms. So you might get a few weak tornadoes tomorrow. You might get a few weak tornadoes tomorrow. There's sufficient 3 cape, but not great 3 cape. Y'all might, so people in this area, y'all might get maybe like a 1 rope tornado, but go down here, y'all might get like maybe a cone. I don't know. So let's just take a look at a supercell composite. I want to see if that's actually what it's showing on the sounding, because that'd be great. Because then we both learn something new. Oh my gosh! Holy crap! I learned something new. Yeah, look at that. It's the same exact sounding. That's pretty cool. Look at that. We both just learned something. That's awesome. Lapse rates. I forgot to mention this. That can actually help a storm form. So as you can see, lapse rates. They pop up. They spike pretty well in this area right here. So putting all of our knowledge together, I'm gonna wrap this video up really soon because I have been recording this for so long. I bet this video's gonna be like over 30 minutes long. But that's just what weather is. It takes a lot of time and work. So putting all of our knowledge together, North Dakota probably won't be as favorable for tornadoes. South Dakota a little bit more, and Nebraska maybe a little bit more. So let's actually take a look at storm reports on the day of this sounding, and so I can show y'all just how bad this was. As you can see, there were 23 tornado reports. That does not mean there were 23 tornadoes. There were only around like maybe 5-6 tornadoes. Enderlin Tornado 2, which was rated EF1. Huh, interesting. So these are all the reports. So as you can see, not very many, like not a bunch of like clumped together tornado reports. You can see it's all kind of spaced out, which showed kind of how conditional this was. There were only just a few tornadoes. There were not many, at all. So let's actually take a look at that website I forgot to mention. Okay, so here's the website. It's called NATOcast. Sometimes it can actually be more accurate than the Storm Prediction Center. I like how it's actually more it's more detailed, in my opinion. Because you can see with all these Storm Prediction Center outlines, they're kind of like jagged, all that. But NATOcast has a very well-defined area of not just tornadoes, tornado risk, which they actually have a 3% risk, which I really like. Sounds so weird to say, but there's also a wind risk, thing, and there's hail, which I think this is for today at the time of recording. It was literally at the time of recording. When I started recording, it was yesterday, but now it's today. So if you do calibration up here, and you click absolute, I would not really do that. I would not use it if I were you, because it seems to overhype what it's actually talking about. So I'd use Storm Prediction Center because it's more accurate. I've actually experienced that firsthand. So you can see it's a tiny sliver of 5%. So we're gonna have to wait and see. I actually didn't know they upgraded it to a 5% risk, which is it's good, because I mean we just saw the conditions earlier in the video of what could happen of those big values, but some convective inhibitions, so the cap. So I think that's what's only warranting a 5% tornado risk. Alright everyone, I hope you enjoy this video and you can walk away now knowing how to forecast tornadoes well or more efficiently, and maybe even if you're completely new to it, you just know how to forecast them now. Once you get the hang of it and you learn a little bit more, it gets relatively routine and it starts to get a little easier, and you actually start to get proud of yourself every time you're right. Which I've been right quite a few times, and I feel really proud of that. If y'all enjoyed this video, please be sure to subscribe. I worked on this video for so long. And some support would honestly be freaking awesome. Help this channel kind of get up off his feet. And that the YouTube algorithm will like me all of a sudden. Hope y'all enjoyed it, and I'll see y'all in the next video.